Deep in the desert, colossal concrete monoliths are rising, consuming massive amounts of power to house modern AI. Wall Street and major tech companies are pouring hundreds of billions of dollars into constructing these enormous server farms. Every dollar rests on a single, massive assumption that gigantic, centralized processing models represent the permanent architecture of artificial intelligence. But if we look at the entire history of computing, the timeline completely contradicts that assumption of permanent centralization. Moving away from centralized structures in favor of distributed networks is a recurring, undefeated pattern in technological evolution. If this historical cycle holds true again, the industry is currently betting its capital on the wrong architectural future. In the 1970s, computing hardware was defined by enormous mainframes, occupying entire climate-controlled rooms. Engineering hit a wall. Room-sized mainframes splintered into distributed networks of smaller nodes. Decades later, this pattern repeated in software. Massive applications splintered into swarms of independent processes. Engineers call these microservices, an organized architecture replacing clumsy monoliths by letting small software pieces run independently. The physics of information growth drive this cycle. As data volumes grow exponentially, massive central structures simply become too rigid and computationally heavy to scale. Decentralization is historically the only architectural model mathematically capable of surviving this accelerating information growth. That brings us to massive large language models like GPT-4. Right now, these systems exist in their own primitive mainframe stage of development. They are entirely monolithic. They try to process every possible data point and execute every conceivable task centrally, within one gigantic framework. Applying the historical law of computing means predicting an aggressive transition away from these massive central models toward something far more distributed. The upcoming model is a sprawling network of much smaller, highly specialized local AI systems. We call these specialized nodes cooperative agents. Instead of relying on one massive framework, smaller AI nodes communicate and pass data packets to one another, collaborating to resolve complex queries much faster. This evolution points toward the future of artificial intelligence being a highly efficient, decentralized swarm of specialized minds. The pace of AI development is so accelerated that this shift to decentralized networks could consolidate in only 5 years. The problem is that physical data centers require multi-decade operational lifespans just to become profitable. When expensive physical infrastructure outlives its underlying technological utility, the financial consequences are severe. The term for this is a stranded asset, a massive capital investment forced into a premature write-down because the technology shifted out from under it. As fleets of smaller, specialized AI swarms take over, the sprawling, centralized data centers currently under construction will become grossly inefficient by comparison. Today's multi-billion-dollar monuments to the artificial intelligence boom are financially destined to become tomorrow's abandoned silent dinosaurs.